Assalamu alaikum and welcome back to my YouTube channel. This is me Sabah Farooq, and today we are going to discuss some hints and formulas of Unit 4 and Unit 5 of grade first year. So, Unit 4 Work and Energy. Work and energy, there are few hints of this chapter. So you can see here some important formulas and concept based studies. As you know, work will be done along x-axis, and it will be said to be done when we apply force on a body and it will change its displacement. So you can see here the cases of work and everything related to work, formula, kinetic energy, potential energy. And then after this, conservation of energy, we should know about it, that conservation of energy means when total energy will remains constant. Energy is neither created or not nor destroyed, but it will remain conserved or constant. Here we have two types of energies, kinetic and potential energies. And then we will observe where the kinetic energy is maximum and where will be the potential energy maximum. Then efficiency is output divided by input multiplied by 100, and then energy concept and kinetic and potential energy. After that, we will study about the ideal and non-ideal cases. And par, you know, par is work done per unit time, that how much work has been done in a given time. So then we will put the formula of work, and then we will get the final equation. Then after that, then after putting the value of work, we will get the final formula for par, that is mgh divided by delta t, and for kinetic and potential energy it will be different. Then we have question and the solution of that one question related to the topic of par. Then work energy principle, and then ideal and non-ideal cases. Ideal cases when there is no loss of energy, and you people should know about ideal case, that in a real case we have some sort of energy losses. So in ideal case we will say there is no loss of energy, and loss of potential energy equals to gain in kinetic energy, means energy of conservation. And non-ideal case will be opposite to that of ideal case. After that, we are moving toward the unit 5. Here's a brief just hints and formulas for these units we are discussing. We will make detailed video of every topic after it. Rotational and circular motion, you know, there is difference between rotational motion, circular motion and linear motion. You know, when body move around a circle or in a curved path, then we must say it is performing rotational or circular motion. But when body will follow the linear path or curved path, it will be translatory or linear motion. As the name indicate, it is about rotational and circular motion. So we will discuss about the terms and related to everything, and related to circular and rotational motion. Angular displacement, angular velocity, angular acceleration, formulas for finding angular acceleration, velocity and displacement, everything will be related to angular velocity. You can see the formulas and a brief introduction of these terms. So after that, we will study about the various graphs for centripetal force. You know, centripetal force is a force that compels our body to move in a center, or we can say centripetal force is a center seeking force, where the direction of acceleration is always directed toward the center. Here are some graphs related to the various type of centripetal force. Then after that, there are some tricky MCQs. And centripetal acceleration, you know, centripetal acceleration, relation of centripetal acceleration with linear acceleration is a is equal to r alpha, where a is linear acceleration and alpha will be the angular acceleration. Then tangential angular acceleration, we will find the tangential acceleration when it will make an angle and tangent angle theta. Then there are relation between various linear and angular quantities. I told you before, there is a relation of linear and angular velocity. For displacement, it will be s is equal to r theta. Then for angular velocity and linear velocity, v equals to r omega, and then for linear and angular acceleration, a is equal to r alpha. Here are some relations of linear motion and angular motion terms. That is, in linear motion, equation of motion will be vf is equal to vi plus at, and for angular motion the terms will be changed. Omega is equal to omega I plus omega alpha t. And similarly for second and third equation and Newton second law momentum, work done, kinetic energy. In short, we can say the terms will be changed in angular motion. Representation of terms will be changed. Then centripetal force or center seeking force. I told you the brief discussion of this centripetal force. There are different components that are dependent on centripetal force, like the formula of centripetal force in term of energy will be 2 into kinetic energy divided by r. Similarly, in vector form and angular form it will be different. Percentage changes, momentum changes, absolute potential energy and gravitational potential energy, and then we will move towards the conservative and non-conservative field. So conservative field, those and the type of field in which work done along closed path will be equals to 0, and non-conservative field it will be not equals to 0. And difference of conservative and non-conservative field is given. So if you have any query related to these two chapters, anything related to what I told you people or what we have discussed, you can ask questions and then we will make further or we will make it more clear. So if you have any query related to these topics or something you are not getting, then tell me in comments and we will make further video. And for more such type of videos, stay tuned and subscribe this channel, like video, do comment and share more and more. Allah Hafiz.